grade 11s, this is just to summarize the section paragraph 2.1 and 2.2 on page 241 to 44 in your textbook. Basically, it boils down to there is energy stored in a bond between two atoms. The energy stored is called the bond energy, and it is important for you to know the definition, so you can go on page 243. Now, the enthalpy is the total amount of chemical potential energy in a system. So this stored energy is also, and if you've got many molecules of different chemicals together, the enthalpy is the total amount of energy that is stored in that system of molecules. The second thing, so enthalpy is also important. Enthalpy. You need to know what the meaning of enthalpy is, and it's on page 242. Now, the bond energy is also the energy required to break a chemical bond, and we measure it in kilojoules per mole. So, for example, in a hydrogen bond, you need 436 kilojoules of energy per mole of hydrogen. So that is energy you need to add to the hydrogen to separate the atoms so that they are alone. With oxygen, you've got a double bond, and the bond energy in oxygen is 494. I see there is a mistake in your textbook on page 243. So there's a mistake here as well. So in the O double bond O bond, you need 494 kilojoules of energy for 1 mole of oxygen to break up the oxygen molecule into 2 atoms. Now, when the hydrogen and the oxygen comes together to make the OH bond, it releases energy, and the energy that is released is 463 kilojoules, and it's for 2 oxygen hydrogen bonds. So to take hydrogen and to add it to oxygen to form water, 463 kilojoules of energy is released. This, where the bonds are broken, is the energy taken in. So it's the energy of if you add the two, the mathematical symbol is sigma, the energy absorbed, and this will total up to the energy released. So the total energy released. Now, to get the right amounts, we actually need a balanced equation. So 2 moles of hydrogen reacts with 1 mole of oxygen to give you 2 moles of water. So actually the 436 kilojoules must be multiplied by 2. So it's 2 times 436 for breaking the bonds in water, and it is 494 for breaking the bonds in oxygen. That is where they get the total energy absorbed equals. Now I hope they've got the correct answer there, because I did not calculate the total amount. 1366 kilojoules of energy. And then here the energy released is twice the energy that is released when 1 molecule of water is 1 mole of water is formed. 463, and that would be, wait a moment, I'm a bit confused here. Okay, so it's 463 for 1 molecule, for 1 OH bond. So in reality it's twice the amount, it's 4 times the amount, so it's twice the amount of 463. Sorry, I misread that information there, and that would be 1852 kilojoules. So you see that more energy is released than what is absorbed. So the change in enthalpy, or the heat of the reaction, is in this case the total energy absorbed minus the total energy released. So the change in enthalpy is negative because we're minusing a bigger number from a smaller number. So it's negative 243 kilojoules per mole. So for every mole of water that is formed, that is the energy released. So this means that the energy of the product is less than the energy of the reactants, because the change in enthalpy is actually the enthalpy of the product minus the enthalpy of the reactants, and that is a negative value. So it also means that the product is more stable than the reactants. So water is more stable than hydrogen and oxygen on its own, which makes quite a lot of sense. And this reaction is called an exothermic reaction. I hope this helps to clarify things just by me going through the basics of the work.